Alright, so what we're looking at here is Unit 2, Lesson 7, and we're going to be looking at something called the ground state versus the excited state and a flame test, etc. This is actually related to a lab that we're going to be doing, which is one of those labs that I mentioned that was not mandatory or required, but it kind of is because they ask about it on the Regents exam. So let's take a look at what we mean by ground state versus excited state. What we have here is an atom of neon. Now, neon, if you remember, has an electron configuration of 2-8. It has 8 valence electrons. So if you look at the dots, you have 2 dots, 2 electrons in the first level, 8 in the second. Now, that's normal. That's where the electrons for neon should be. That's called its ground state. But we can make electrons in atoms do strange things. We can make them move to different locations, places where they're not normally found. That would be called the excited state. So for example, if you take a look at what's on this side, it is the same atom, except what we've done is we have forced one of the electrons in the second level. Remember that originally it had 8. So if you look at what we have 1, 2, 3, 4, 5, 6, 7. The 8th electron we forced to move or to jump further away from the nucleus. Here's the 8th electron. It's not supposed to be in the third level. It's supposed to be here with the other 7 valence electrons. We say that that atom is now in the excited state because you have at least one electron that is not where it's supposed to be. It's a little bit further away from the nucleus. It does not leave the nucleus. It does not leave the atom completely. It temporarily moves a little bit further away but never leaves completely. That's said to be in the excited state. The important part of this is, does that electron stay there? It does not stay there. It doesn't stay there for very long at all. It almost instantaneously will drop back down to where it's supposed to be, which is called its ground state. Now what's important about that is that when that electron goes from the excited state to the ground state, it gives off energy in the form of light. And that's the important part of this whole concept here. Being able to recognize an atom being in the ground state or the excited state, and what happens when an electron goes from the excited state back down to the ground state, and that's going to be related to a lab that we'll do called the flame test. So let's take a look at a little bit more detail here. And this is just giving you definitions. I don't really think that you need to know the definition for excited state versus ground state, but you need to be able to recognize when something is in the ground state versus the excited state. So basically, when an element's electron configuration is exactly as it is on the periodic table, it's in the ground state. So for example, that's what lithium normally looks like. Lithium, if you look at its atom, if I do the Bohr model, it has 3 protons, 4 neutrons, and it has 2 electrons in the first level. I'm only going to draw this, and 1 electron in the second energy level. That's in the ground state. We can make electrons, either these 2 electrons or this electron, jump a little bit further away from the nucleus, and that's what would be called being in the excited state. So for example, if I made one of these electrons jump to the second energy level, so let's say we made this electron jump here. Instead of being a configuration being 2-1, it would be now 1-2. That would be an excited state. I can even make that electron jump even further away from the nucleus, but we don't need to get into that here. So as I said, one of the things that you need to be able to do is to determine if an electron configuration is in the excited state or the ground state. So here is some practice, and you definitely need to do these. So first thing, say, okay, well, wait a minute. Is this configuration on the periodic table? Now, there is no electron configuration 1, 1, 1. So what you have to do is we have to figure out, well, what element is that? And if you look at it, it has 3 electrons. That's going to be lithium. That's in the excited state. Now, let's take a look at 273. Nowhere on the periodic table is there 273. The closest to that would be 282. If one of these electrons jumps to the third level, that would make it 273. So this is in the excited state. And that happens to be magnesium in the excited state. 282, well, that is magnesium, so that's in the ground state. Can you find this on the periodic table? Absolutely. That is calcium. Can you find this one on the periodic table? That's in the excited state. This would be in the ground state. This is in the excited state, etc. And I think that you get the general idea. This would also, the last one would also be in the excited state, because you notice how there's a 5 here. So that's how you figure out the difference between the ground state and the excited state configurations. But we need to take it a step further. How does an atom become in the excited state? Well, here's what you do. And this is just some general information. When electrons absorb energy, they jump to a higher energy level, which is called the excited state. That excited state is extremely unstable, and it's temporary. It only lasts for a split second. And those excited electrons will drop back down to their lower level. The important thing is that when they do drop down to that lower level, when they do go from the excited state to the ground state, they give off energy in the form of light. And this is just kind of giving you a summary. When an electron goes from the ground to the excited state, it has to absorb energy. Don't worry about the dark line spectrum. That's not something you need to worry about. When that electron goes from the excited back down to the ground state, energy is released in the form of light. That light is called the bright line spectrum. Now, that light that's given off, if we look at that light through an instrument called a spectroscope, you'll see that that light is actually a lot more complex than it looks. And I think it's easier if we just do that when we go over the lab instead of looking at these, because it really can't base it on anything. Sorry. Every element gives off a specific color of light, which is called its spectra. They're kind of unique, kind of like the way a human's fingerprints are unique to each person, right? No two people have the same fingerprints. Well, no two elements have the same spectra or colors of light that they give off when their electrons go from the excited to the ground state. It can actually be used, the spectral lines can actually be used to identify elements. So let's quickly run through and do these examples. It says here, which of the following is a ground state configuration? Well, it has to be on the periodic table. The only one that you'd find on the periodic table would be 281, that is sodium. The rest are all in the excited state. Now the opposite, they're asking which is in the excited state, so you're looking for the one that is not on the periodic table. So the one that would not be on the table is 261. That would be 89. That is fluorine, but in the excited state. Give one possible example of an excited state configuration for oxygen. Well, oxygen is normally 2,6. So you could make it 251 would be an example. But you have a whole bunch of examples that you could put, right? You could put also 17, because the second energy level can hold 8, so it still can hold another one. So that's another example. So there's more than one. Let's see what we got here. A lot. When atoms of an element in the ground state absorb enough energy, some of their electrons, well, when a ground state electrons absorb energies, they sometimes will jump to the excited state. When excited electrons lose energy, they will fall back down to the ground state and give off energy in the form of light. So just repeating what we talked about before. Okay, 7 is a dark line spectrum. We don't care about dark line spectrum. They don't even ask about that, but they do ask about the bright line spectrum. The bright line spectrum is the colors that they give off when the electrons go from the ground state to the excited state. So let's take a look. A bright line spectrum is produced when electrons emitting energy and they're falling back to the ground state. Okay. This number 8 is something that you're probably not going to understand until after we have done the lab. But here's what happens. When you look at a gas's spectrum through the what's called a spectroscope, you'll see different colors of light, and they will line up. Now, these are all black and white, obviously, but you might be red, blue, orange, and green. And what you have to be able to do is, and this will become easier when you see the lab, we have a mixture, and this mixture, when you run that mixture and you excite its electrons, it gives off these specific colors of light in these specific spots. So what you have to do is you have to match up these lines with the unknowns. Well, obviously you can see that the unknown definitely contains gas A, because all of those match up. It also contains gas D. It doesn't contain C because you don't see the letter, these lines do not match up. So what gases present would be A and D. And again, you'll see this when we go through when we do the lab on flame tests and emission spectra. And I believe that that is it for this lesson. This is just on your notes, it's just stuff that you have to study. So we're done with this lesson.